All right, this is the second proof in our proof festival. I'm looking at this statement to prove or disprove, which has cosines and secants in it. The right side is equal to 0, so obviously the most complicated side is the left side. So I'm going to, again, declare that I'm doing the proof. I'm going to go ahead and write down the left side. All right, so there it is. So different options as to what to do. I guess the two things that come to mind is I could just find a common denominator right off the bat. That's one thing I could do. I could also change everything to sine and cosine. So I would change the secants to 1 over cosine. So why don't we do that? I have 1 plus 1 over cosine and 1 over cosine minus 1. And that's alpha, cosine alpha. Plus, I'll leave the other fraction alone. Okay, looking at that left fraction, I see that I can clear it by multiplying by cosine over cosine. So when you do that, whoop, that was a mistake. Okay, when you do that, you get cosine alpha. Okay, I'm distributing in here, plus 1. Okay, and then I get 1 minus cosine alpha. Okay, so now I have this statement. I guess I notice here that these two are awfully close to each other. They're actually opposites of each other. So why don't we get a common denominator? Why don't we change one of the denominators somehow? So let's change the common denominator into cosine alpha minus 1. Okay, so we're going to keep this one. And how are we going to change this one? Well, we have to multiply the top by -1 and the bottom by -1. So if I do that, I get negative cosine alpha minus 1 over that cosine alpha minus 1. So then that's plus 1 plus cosine alpha minus 1. Okay, so then I have a common denominator, so let's just put it together. Negative the opposite of cosine alpha minus 1 plus 1 plus cosine alpha. If you look at that, you see that those cancel and those cancel, so I'm left with nothing. I'm left with 0, and that's equal to the right side. So all that mess was equal to 0. Proved.